Hi friends, welcome to VG Nursing channel. In this NAFSA preparation, next we are going to see acid-base balance and its imbalance. This is difficult topic, but if you understand, it will be very easy. Okay, so please listen with full attention. First, what you are going to see is normal values. Okay, normal pH value is 7.35 to 7.45. Bicarbonate normal level is 22 to 27, or we can say 22 to 26 also normal. Carbon dioxide level 35 to 45 mm mercury is normal. Oxygen partial oxygen is 80 to 100 mm mercury. Oxygen saturation level is 96 to 100 percentage. And next is base excess or base deficit. This we will see for metabolic acidosis or alkalosis. This value we will see for metabolic acidosis or alkalosis. Okay, if it is less than -2, below -2, it indicates acidosis. Okay, if it is more than +2, it indicates alkalosis. To find the cause, we have to compare with anion gap to find the cause of this metabolic acidosis or alkalosis. Okay, this is base excess or base deficit. This is base deficit. This is excess. Okay. Okay, next we move on to next slide. Memory tips. This is respiratory acid base imbalance. Okay, the acid base, everyone know the memory tips. Acid base imbalance is Rome. Okay. Rome. That means respiratory is opposite and metabolic is same. That means if pH is less and partial carbon dioxide is more, that means respiratory acidosis. Okay, if pH is more and first we have to see first pH level, then second is carbon dioxide level, third one is bicarbonate level. Okay, first we see pH level, it is increased, that means it is alkalosis. Okay, then carbon dioxide level we see this is decreased. Okay, that means respiratory alkalosis. And next we see bicarbonate level, it is normal. Okay, we have to first see pH level, carbon dioxide level, and then bicarbonate level. Next we see what you see, this is decreased. Okay, that means acidosis. And next you see carbon dioxide level, it is normal. So we next move on to another one, third one, bicarbonate level, it is also decreased. Okay, so metabolic same, pH also decreased, metabolic also decreased, that means metabolic acidosis. In this see pH increased, carbon dioxide level same, and then bicarbonate level increased, both are increased, that means metabolic alkalosis. Okay, next one is compensation. This is a very, you need to understand this because you will get confused in this more, so just listen carefully. PH is decreased, that means acidosis. Next we move on to carbon dioxide level, it is increased, that means respiratory acidosis. But if you say respiratory acidosis, the metabolic level will be normal, but this also increased, that means this is trying to compensate. Okay, this trying to bring back the pH level to normal. So this is respiratory acidosis with metabolic is compensating. Okay, the next one is pH increased, that means alkalosis, and carbon dioxide level also increased. See, if it is metabolic, always the respiratory is opposite, but in this both are same, so you ignore this. Next you go to bicarbonate level, you see it is also increased, so it is metabolic alkalosis with respiratory trying to compensate. Okay, in compensation you see both levels are increased. Okay, both levels are increased. Then next one is pH level also decreased and carbon dioxide level increased, so you can say it is respiratory acidosis. But you see metabolic also decreased, it is not also trying to compensate. Okay, if it try to compensate, it will be increased, but the base level also very less. So this means it is metabolic and respiratory acidosis. Okay, base level also not compensating, it is not increased. Okay, and see this pH level is increased, so alkalosis, and this is opposite, so respiratory alkalosis. You can say respiratory alkalosis because respiratory opposite. Okay, and next one you see it is increased. See, in alkalosis the acid level should be increased, but the base level is increased in this. Okay, if acid level is increased, you can say it is compensating, but the base level is increased, so it is metabolic and respiratory alkalosis. Okay, okay, means if it is acidosis, if it is alkalosis, the acid should get increased, but in this alkalosis base level is increased, so it is like this. We can say metabolic and respiratory alkalosis. If any doubts, please put in the comments, I will clarify your doubt. Okay, we move to the next one. Next we move on to partial compensated and fully compensated. Okay, in this first we see pH level is decreased, so it is acidosis. Next we see carbon dioxide level, it is increased. Respiratory is opposite, so we can say it is respiratory acidosis. See the next third one, it is bicarbonate level also increased. In both of these H plus is increased, that means acid is increased. In this bicarbonate is increased, so the base is increased to compensate this, so it is respiratory acidosis with partial compensation of bicarbonate. Okay, the next one is pH level is normal, so fully compensated, but carbon dioxide level is increased, so we can say it is respiratory acidosis was fully compensated. We can say the third one also we have to see, this is bicarbonate level is also, base is also increased, acid also increased, so which one is compensated in this, so we have to see this pH level to identify this. I will give an example. Okay, just wait. See the next one, acid is pH is decreased, so acidosis. Carbon dioxide level also decreased, so we can say it is not the respiratory is opposite, so we move. See the next, bicarbonate level is also decreased, so it is metabolic acidosis with respiratory is compensating, because respiratory is H plus is acid, so acid is decreased to compensate. Okay, this metabolic acidosis with respiratory is compensating. The fourth one we have to see the fully compensated with example I told you earlier. Now see pH is 7.43, carbon dioxide level 55, bicarbonate level we see it is 40. Okay, second one example, pH 7.37, carbon dioxide level 65, bicarbonate level it is 35. Okay, now we see this pH is 7.43, it is normal. 7.35 to 45 is normal, so it is fully compensated. Carbon dioxide is increased, acid is increased, so we can say respiratory acidosis, no we can't say. Just see the third one, it is also increased, acid is also increased, base is also increased. Okay, but we see the pH is with in the border range, within the border range of 7.45. Okay, so previously the pH is more, so it is also more, the bicarbonate also more, so we can say it is metabolic alkalosis. Previously it was metabolic alkalosis with respiratory is compensated, so it is fully compensated metabolic alkalosis. Okay, this one, this is the example for this one. Okay, now see the example for another one. This pH is 7.37, it is normal. Carbon dioxide level is 65, increased. Bicarbonate levels is 35, also increase. Now we see the pH level. The pH level is the base for the to identify this. pH is 7.37, so in the border range of 7.35. So earlier it was acidosis. Now see, in acidosis respiratory is increased. In acidosis respiratory it is would be opposite, but this was in so and the metabolic is increased. Okay, so it is respiratory acidosis. Okay, respiratory is opposite. Okay, this respiratory is opposite, so it is respiratory acidosis. The base was increased to compensate this. The border and the pH level, With this only we can identify it is fully compensated, which one is fully compensated. Okay, please understand. Okay, if you have any doubt, please put in the comment.